Alright, here's a video of the oscilloscope working the code block in this case. So both the UI, the ADC, and then also the display showing the effects of it. First off here, we just have the normal oscilloscope with some randomized data being played in here. It just goes from the lowest voltage to the highest voltage and then sort of repeats that. So right now we're sort of zoomed in. And so here, this UI test is going to prompt me to enter the values of buttons that would be encoders and scroll wheels that we'll actually have on the physical UI. So this first one, I can open up the menu by hitting 1. Now I have the menu here. And now if I wanted to make a choice, let's say that we want to add a measurement to the top left corner of wave 1. I know off the top of my head what I have to do that, which is going to be navigating through this menu like so. And now you'll see that I've opened up the channels menu, I've selected it, and now I have my own options here. So again, I can move over some more clicks here, which is registered as rotary encoder clicks. And I can select something, which in real time this would be updating, so it'd actually be a lot more smooth to the user. And you'll see here that I've actually selected measure 1 off, or measure on and off. So measure 1, channel 1 is the screen here, so I can turn on the peak to peak and the period measurements for it. So now if I go here, I could hit 1. I'll make sure to not get rid of the display. And now you see that I've turned it on with some input, and now it's reading out the peak to peak, which is this right here. Similarly, I could move through other functions of the display, like if we go here, zeros all the way. Now I've opened up the menu again and back to channels. So I'll go back one more time, and now I'm on the regular menu. Now if I wanted to mess with scaling, say we could move 12 encoder clicks over, which is an adjustable sensitivity. I could select that, and then I'll do this here. And now you see that I'm on the horizontal and vertical scaling option. So now I can change these values how I want. So for example, take note of how spread these waves are right now. I won't change my vertical scale, but let's up the horizontal scale, so I should widen the thing, which you see more of a signal. So let me go up by 200 clicks, like this, and we won't change anything. And just like so. Well, let's see here. Try that one more time. All right. And so now you actually see that it's spread out. Now you can actually see the randomized data. All it does is it goes low from high and then it restarts again. So it's sort of like a sawtooth wave. But we've zoomed all the way out. We used to be in just this portion here, and now we're looking at the whole waveform. Similarly, I can do this with the vertical scale. So now if I wanted to make the vertical scale much different, do 200 clicks, zeros here, zeros there. And now you'll notice that they're all a lot smaller because they actually got compressed vertically because of the vertical scale. And then this is sort of hard to show on video here, but this is just all the data points, and at least for my interface validation where I'm taking in 4,000 data points and plotting out 320, here's the first 20 values of my 2 channels of 4,000, and then this is being converted into voltage data, and then I'm selecting 320 points depending on the stride, indexing the array, which is based on the horizontal scale. These are my 320 points that corresponds to 320 pixels across. So those are the 320 points that I'm doing. Similarly, I won't show in this video, but I could do the same thing with the voltage trigger. I could turn on and off channel 1, channel 2. I could also choose whether or not to display these waveforms on the oscilloscope. But this is the working code block. And then here, if I scroll this down, it is split into display code, ADC code, and UI code. So this performs all the interface validation of everything.